All right, finally number 14 and 15 from the old final exam for Math 084. All right, here's 14. Absolute value of 2p minus 1 plus 5 equals 12. We're solving for p here, and the key to solving an equation with an absolute value in it is first isolate the part with the absolute value. So this part here, we're going to get this part by itself first. So to get the part in the red box here by itself, first we just need to get this 5 out of the way. So subtract 5 from both sides, like this. Then we get absolute value of 2p minus 1 equals 12 minus 5 is 7. All right, now we can deal with the absolute value. So the absolute value of something can be 7 in two ways. Either the thing inside the absolute value, so 2p minus 1, either this thing inside the absolute value can be equal to 7, or the second way this can happen is that this thing inside the absolute value could be equal to negative 7. Right? Either way, once you take the absolute value, it's going to be equal to 7. So, of course, the thing inside this blue box is actually 2p minus 1. So we get 2p minus 1 is equal to 7, or 2p minus 1 is equal to negative 7. Now we can solve each of these because each of these is just a regular linear equation. So add 1 to both sides. Over here, also add 1 to both sides. Okay, so we get 2p equals 8, or 2p equals negative 6. Now we can divide by 2. So we get p equals 4, or p equals negative 3. So there are two solutions to this equation, p equals 4 and p equals negative 3. All right, here's number 15. This quotient of polynomials, 3x cubed minus 12x plus 6 over 3x minus 9. The thing to remember about dividing polynomials is it works almost the same as division by division of integers. So we'll set it up in the same way. 3x minus 9 is dividing 3x cubed. One trick to keep yourself organized with dividing polynomials is leave space here for every power of x. Our dividend up here in the top of our division doesn't have an x squared term, but we should leave room for x squared terms here. So we can do that by putting 0x squared here. That's the same as the dividend, but it's making the x squared explicit so that we can see it, so that we can leave room for it. So minus 12x plus 6. Okay, so what times 3x is 3x squared? That's going to be 3x cubed. That's going to be x squared. So now we take x squared, we multiply by 3x minus 9, and that goes right down here. So x squared times 3x is 3x cubed. X squared times negative 9 is minus 9x squared. And then we subtract this. When you're subtracting this, remember to distribute this minus sign to both of these terms. All right, so 3x cubed minus 3x cubed, that's no x cubed, so the x cubes cancel. Good, that was the whole point. And then 0x squared minus negative 9x squared, so 0x squared plus 9x squared, that's 9x squared. And then minus 12x plus 6. All right, now to check if we're done with our division, we look at our remainder here. It has an x squared term. The degree of our remainder is not smaller than the degree of our divisor, so we keep going. Do the whole thing again. So what times 3x is 9x squared. That's going to be plus 3x. And then we take our 3x, multiply by our divisor. 3x times 3x is 9x squared. 3x times negative 9 is negative 27x. And then subtract this. 9x squared minus 9x squared is no x squared, so those cancel. Negative 12x plus 27x, that's going to be 15x, and then plus 6. Almost out of room here. All right, now again, the degree of our remainder is not smaller than the degree of our divisor, so we'll keep going. What times 3x is 15x? That's going to be 5, so plus 5. 5 times 3x is 15x, and 5 times negative 9 is negative 45. And then subtract that. Again, the x's cancel, and then 6 plus 45, that's going to be 51. So our final answer is the quotient, x squared plus 3x plus 5 plus the remainder, which is 51, over the divisor, which is 3x minus 9. All right, and now we're finally done with that old final exam. Let me know if you have questions about any of the problems from this exam or any problems from homework or from quizzes.